Welcome to Shridevi Classes, official YouTube channel of Shridevi Women Polytechnic Hanumangarh, where we improve interest and confidence in science, engineering and design subjects. In our playlist of applied mechanics, in this learning video, second to practice numerical problem based on Parallelogram of Forces Theorem, we will discuss 4 advanced level numerical problem based on Parallelogram Forces Theorem, where we will understand analytical skills to find out answers. We will use both magnitude formula of resultant and direction formula of resultant, and will use algebraic identity to solve problems of applied mechanics. So let's start. Two forces P of 40 Newton and Q of 50 Newton act simultaneously at a point, and their resultant R is perpendicular to the force P. We have to find out angle between the two forces P and Q and the magnitude of resultant. Now here the magnitude of resultant is given by this relation, and apart from the value of two forces P and Q, we need the angle between two forces which is not known in the problem. So to find out this angle between two forces, we have to use the direction relation of resultant with one force P, and in this relation we have given alpha P and Q, so we can find out angle theta between two forces, and we'll use that theta in this first relation to find out the magnitude of resultant. The direction formula is as tan alpha is equal to Q sin theta divided by P plus Q cos theta, where alpha is angle of resultant with respect to force P. Since it is given that a resultant is perpendicular to force P, so alpha is 90 and tan alpha, that is tan 90 degree, become infinity, and when this ratio is infinity, it means the denominator function P plus Q cos theta is 0, and when we substitute value of P and Q, which is respectively 40 Newton and 50 Newton, we will find that 40 plus 50 cos theta is 0, or 50 cos theta is minus 40, or cos theta is negative 0.8. The negative value of cos theta straightforward indicates that this theta is more than 90, and to find out theta from cos theta, we'll take inverse function of cos theta. So cos inverse of cos theta is theta, and when we substitute value of cos theta is 0.8, negative 0.8, the cos inverse negative 0.8 comes as 143.13 degree. So the angle between two forces 40 Newton and 50 Newton here is 143.13 degree. Now we know the value of theta as 143.13 degree. We can use magnitude relation, and resultant square is P square plus Q square plus 2PQ cos theta. When we substitute value, P is 40, Q is 50 and cos theta is negative 0.8. 40 square is 1600, 50 square is 2500, and when we multiply 240, 50 and 0.8, this comes with negative sign 3200, and this sum subtraction is got a resultant value 900, and when we take square root, the magnitude of resultant comes as 30 Newton. So from direction formula, we have obtained angle between two forces, and we have used that angle between two forces to find out the magnitude of resultant. In this new problem, we have given two unknown forces P and Q which act at a point, and when the angle between two is 60 degree, the resultant is 110 Newton, and when the angle between the same two forces P and Q is 90, the resultant will become 90 Newton, and we have to find out the magnitude of two forces P and Q. So our magnitude relation of resultant is R square plus P square plus Q square plus 2PQ cos theta, and theta for two conditions with magnitude of resultant is given. So we can have two relation of P and Q from this magnitude formula. Now in this question, neither angle of resultant with one force is given nor it is required to calculate. So we won't use this direction relation in this problem. We'll use only magnitude relation. As per Parallelogram Forces Theorem, the resultant of two forces P and Q with angle between them theta is given by this relation R square is equal to P square plus Q square plus 2PQ cos theta, and when the angle between the two is 60 degree, resultant is 110 Newton. So in place of R we have substituted 110, and P and Q are two unknown, and angle theta is 60 degree, and cos 60 is 0.5 multiplied by 2 will become 1, and 110 square become 12100. So this become our first identity. Similarly, one angle is 90 degree. When we substitute theta 90 degree, resultant is 90 Newton. 90 square is 8100. Cos 90 is 0. So this term 2 pq cos theta becomes 0. So p square plus q square equal to 8100 become our second identity, and we will simultaneously handle these two identity to find out value of p and q. And for that we'll first find out value of pq, as we know the value of p square plus q square, and then we'll use these two to find out p plus q and p minus q to find out the value of two forces p and q. So our two identity with angle between two forces 60 degree is 12100 equal to p square plus q square plus pq, as cos 60 is 0.5, and the second identity for 90 degree is simple Pythagoras. Resultant 90 square, that is 8100, is equal to p square plus q square. Now if we subtract the two, we'll get subtraction of 12100 minus 8100 as pq. So pq comes as 4000. Now we can use two identity. One is p plus q whole square and second is p minus q whole square. P plus q whole square is p square plus q square plus 2pq, and p minus q whole square is p square plus q square minus 2pq. We know the value of p square plus q square sum as 8100 and pq as 4000. So when we find out p plus q whole square, then it is p square plus q square 8100, and 2pq is 2 times of 4000, 8000, and the sum 16100 is p plus q whole square. When we square root 16100, we will get value of p plus q as 126.89. Similarly, p minus q whole square is p square plus q square minus 2pq. pq is 4000 and p square plus q square is 8100, and when we solve it, it comes as 100, and by square root p minus q becomes square root of 100 as 10. And now we'll use these two identity, the sum of p and q as 126.89 and the difference of 2, that is 10, to find out the value of p and q. Our two identities are s, and when we add 2, q get cancel out and 2p become 136.89, and to find out p, when we divide this by 2, it comes as 68.45 Newton, and from sum of p and q, when we subtract p, we'll get q as 58.44 Newton. In this new problem, we have given that two forces P and Q act at an angle 100 degree, and the resultant got a magnitude of 100 Newton, and resultant makes an angle 60 degree with force P. We have to find out two unknown forces P and Q. So in this example, we'll use both the relation of magnitude of resultant and the direction of resultant with force P, and we'll prepare two equations in two unknown P and Q, and we'll solve those two algebraic identities to find out value of P and Q. Let's first find out interrelationship between P and Q, and for that use this direction formula of resultant with force P as q sin theta upon P plus q cos theta, and alpha is given 60 degree and theta is given 100 degree. P and Q are two unknown. Tan 60 degree is root 3, sin 100 is 0.9848, cos 100 is negative. When theta is more than 90 degree, cos theta become negative. So cos 100 is negative 0.1736. So when we substitute value of tan 60, root 3 or 1.73, sin 100 and cos 100, and when we cross multiply, this become 1.73 times P minus 0.1736 Q is equal to 0.9848 Q, and now we separate the quantity of P to one side and Q is to other side. The multiplication of 1.732 with 0.1736 is 0.3006, and when Q is transferred to other side, the two Q numeric figures 0.9848 and 0.3006 get added to 1.2854 Q. So 1.732 P is equal to 1.2854 Q, and the value of P in terms of Q is given as 1.2854 divided by 1.732 Q, that is 0.742 Q. So we have obtained the relationship between P and Q from this direction formula, and the same relation is used to substitute P in terms of Q in this relation, and we'll find out the value of Q from magnitude of resultant relation. So in this magnitude relation, when in place of P we substitute 0.742 Q, we'll get resultant resultant is given 100 Newton, so R square is 100 square. In place of P, we have substituted 0.742 Q. Q square is taken as it is, and P again is 0.742 Q. And the cos theta for cos 100 is negative 0.1736. When we solve, it is 100 square, 0.742 square is 0.55, Q square is as it is, and 2 multiplied by 0.742 multiplied by 0.1736 comes as 0.257, and the sign of this relation is negative. So all terms got common Q square, and when numeric figure 1.55 is added and 0.257 is subtracted, it comes as 1.293 Q square. So Q square is 10000 divided by 1.293 as 7733.95, and when we square root this figure, Q comes as 87.94 Newton, and P and Q got a relation. So P, which is 0.742 times of Q, and Q is 87.94, so P comes as 65.25. so this P unknown force is 65.25 Newton, and this Q is 87.94 Newton. When they act at 100-degree angle, the resultant comes as 100 Newton and will make an angle 60-degree with force P and 40-degree with force Q. And it is again clear that resultant is closer to larger magnitude. Q is larger than P, so angular position of resultant is close to Q. Two unknown forces P and Q act at a point, and the resultant of 2 is 70 Newton when the angle between two forces is 60-degree. And for the same forces P and Q, when the angle between two changes to 120-degree, resultant magnitude become 50 Newton. We have to find out two forces magnitude P and Q. Now we have given resultant magnitude for two conditions with angle theta, and P and Q are two unknowns. So from this relation of magnitude of resultant, we can find out two mathematical identities in P and Q, and when we solve those two mathematical identities, we can find out magnitude of P and Q. And in such type of problem, neither angle of resultant with one is given, not it is to be obtained. So we won't have to use a direction formula in this problem. We have to use only magnitude formula, that too twice. This is our direction formula. Resultant magnitude R is related to magnitude of two forces P and Q and angle between the two theta, as R square is equal to P square plus Q square plus 2PQ cos theta, and the when angle between the two is 60-degree, theta is 60-degree, resultant is 70, so R square is 70 square, 4900, P square plus Q square plus 2PQ cos 60. Cos 60 is 0.5. 0.5 multiplied by 2 become 1. So P square plus Q square plus PQ become 4900 as our first identity. Similarly, when the angle between the two becomes 120-degree, theta is 120-degree, the resultant is 50. So resultant square is 50 square. 2500 is equal to P square plus Q square plus 2PQ cos 120. Cos 20 is negative 0.5, and this identity become P square plus Q square minus PQ. Now to find out P and Q, we will generate two identities, one of P plus Q and second is P minus Q, and to find out these two values, we will find out values of P square plus Q square first and PQ in second relation, and we'll use those two together to find out P plus Q and P minus Q, and then those two identities are used to find out value of P and Q. This is a very systematic approach. So let's first add the two. When we add, PQ get cancel out, and the sum of 4900 and 2500 is 2 times P square plus Q square. So P square plus Q square is the sum of 2, 7400 divided by 2, that is 3700. And when we subtract 2, P square plus Q square get cancel out as their coefficient is the same, and this PQ become 2PQ, and 2PQ is difference of 4900 and 2500 as 2400, and when 2400 is divided by 2, we will get product PQ as 1200. And now we will use these two identities, P square plus Q square as 3700 and PQ product as 1200, to find out P plus Q and P minus Q. We have to use one identity, that is P plus Q whole square, as P square plus Q square plus 2PQ, and we we know the sum of p square plus q square is 3700 and pq is 1200. When it is multiplied by 2 become 2400. So p plus q whole square is sum of 3700 and 2400 as 6100, and when we square root the sum of two forces magnitude p and q, p plus q comes as 78.1 Newton. Similarly, the identity is p minus q whole square is equal to p square plus q square minus 2pq. We know the value of sum p square plus q square as 3700 and product pq as 1200, and when it is multiplied by 2 it become 2400 and the difference become 1300 as p minus q whole square, and when we square root p minus q comes as square root of 1300 or 36.06. So we know sum and we know the difference, and when these two identities are added q get cancel out as its coefficient is the same. So 2p become the sum 114.16, and when it is divided by 2 p become 57.08, and from sum when we subtract p we'll get q as the sum 78.1 subtracted the value of p as 57.08, the q comes as 21.02 Newton. So students, in this class we have solved some advanced numerical problem based on parallelogram of forces theorem. We learned how to apply algebraic identities in such mechanics problem by framing relation of magnitude of resultant and direction of resultant, and finally we have obtained the value of unknown that is required. Now practice of these type of problems can strengthen your conceptual understanding, so do some more practice of similar type of problems. Thanking you for the watching. Please like, share and subscribe for more such knowledge on engineering, science and design subjects. Thank you very much. You can also join our Shridevi classes YouTube channel to support financially this academic activities of women empowerment, that is Shridevi Women Polytechnic Hanumangarh.